Choosing which collection class, or collection framework as it's called, that will hold your collection can be confusing unless you know the options and approach it logically. This lesson looks at some of the things that should be considered. You want to be able to set things up so later changes have a minimum impact. The first urge is to create a collection object by using one of the specific references, like this. But this could create a problem later if you need to change, for example, to some other list or some other set. You may want to use the superclass and deal with the collections in a more generalized form, like this. Of course, with the addition of generics, this consideration is a bit different and not as important or as flexible as it once was. Anyway, the three key interfaces of the framework are set, list, and map. A set offers a collection of unique elements. A list provides an ordered access by index, but doesn't guarantee uniqueness. The map interface is different. Instead of just offering a collection of single elements, a map provides a collection of key and value pairs. You locate the values through a lookup operation. The items stored inside a collection are often referred to as the elements of that collection. There are three fundamental set implementations: a hash set, a tree set, and a linked hash set. All three contain a collection of unique elements. Typically, you use a hash set, which maintains its collection in a completely unordered manner. If what you want is organization, you can use a tree set to keep the elements in sorted order. They come back sorted from the iterator. Finally, there is a linked hash set. While a hash set has an undefined order for its elements, a linked hash set returns the elements in the order they were inserted. Be sure you need that order, because keeping things in order in a tree set or a linked hash set adds to the runtime cost. The list interface offers two implementations: an array list and a linked list. There is actually a third implementation of vector, but this is part of the historical collection of classes from an earlier release. It's included as a retrofit, but it's not really part of the new collection stuff. Of the newer classes, the array list provides quick indexed access to its elements and works best when elements are only added and removed at the end of the list. This is because the array list performs an internal move operation when an element is added or removed. By comparison, linked list works best when add and remove occurs anywhere in the list. A linked list doesn't do internal move operations for an element to be inserted or removed. It just manipulates the pointers. But here again, you should be aware that a linked list adds flexibility, but comes at an added cost. It just depends on what you need to do. The final core interface is map. There are 5 implementations of the map interface: hash map, tree map, linked hash map, identity hash map, and weak hash map. There is also one historical implementation: hash table. There are more implementations of map than the others, but it's actually easier to choose the right one. A hash map is the most usual. It's simple and serves well in most cases. The tree map is one you'll need if you need to maintain the keys of the map in a sorted order. However, if you only need the keys sorted when you're done, just once at the end, it's better to simply keep everything in a hash map than move it all to a tree map at the end. You can create a new tree map by using the hash map as the argument on the constructor, and it all gets sorted at once. The linked hash map works like the linked hash set. It maintains the ability to return elements in the order they were inserted. The identity hash map uses the double equal sign to check for equality of elements. This one is not used that often, but it's useful where you need a strict reference for equality. The weak hash map is also rarely used. It keeps its keys as weak references. A weak reference allows a program to maintain a reference to an object, but it doesn't prevent the object from being claimed by the garbage collector. If it turns out that the weak reference is the only reference to that object, it may be claimed by the system. The hash table is typically avoided in favor of the hash map. These pointers should help you choose a collection, although sometimes it just isn't obvious. The only way to choose is to run them both and compare the results. If you're unsure which to try, write a quick test program that manipulates each one several thousand times. That should tell you which one works better for your specific requirements.